All right, page 49, number properties. So the commutative property says you can change the order in addition and multiplication problems. The answer stays the same. You can do this with variables, or you can do it with numbers. Could even do it with, say, 3 numbers. So we could say 3 plus 5 plus 7 equals 3 plus 7 plus 5, swapping those two. Or we could have swapped the 3 and the 5. Multiplication is similar. We can use it with variables. Notice that we usually write these in alphabetical order, but x times y times x, those mean the same thing. We just write it in alphabetical order so that it's consistent. And 1/2 times 5 times 8 is the same as 1/2 times 8 times 5. Now that's useful because 1/2 times 5, that's 2.5 times 8, let me think. Or 1/2 times 8 is 4, 4 times 5 is 20, done. So this can save us a lot of work. The associative property says that we can change the grouping. Change where they associate. Commutative has commuting, like commuting from one place to another. Notice that is commutative, not commutative. A lot of people make that mistake. So associative, we can change the grouping, we change the parentheses, the answer stays the same. Notice that the order of the terms remains the same, it's just the grouping that changes. So for example, x plus y plus z, here we're adding y and z and then adding x. Well, I could just as easily add x and y and then add z. Or equivalently, if I have 1/4 plus 7/4 plus 9, that's 1/4 plus 7/4 plus 9, which is an easier problem for me to do. We can also have x times yz equals xy times z, or 2/3 times 9 times 2 equals 2/3 times 9, which is easier to do, times 2. The identity property. The identity property says that I can add 0 to something without changing it. Or I can multiply it by 1 without changing it. So adding a 0 to a number does not change the value of the number. Multiplying a number by 1 does not change the value of the number. They maintain their identities. So we have x plus 0 equals x, 15 plus 0 equals 15, or x times 1 equals x. 15 times 1 equals 15. And finally, the distributive property. You'll notice that this table is a little different here. Instead of having one side and then the other, it's all the same. That's because multiplication has a distributive property over addition and subtraction. So it's not the distributive property of addition or the distributive property of multiplication. It's just the distributive property which involves both of those things. So A times B plus C is AB plus AC. That's the distributive property. It says that I can distribute this A to the B and to the C. Works just as well with subtraction. Just use a subtraction sign here as well. And we can do it with variables, with numbers, with a little bit of both. And similarly, that's 2x minus 4. I can even simplify this if I want. Negative times a negative. Think about it. Yep, positive. 2 times 4, 8. I forgot my x, sorry about that. negative 2x plus 8. So let's take a look at some examples of combining like terms. Let's start with number 1. Negative 4 plus 7 times 1 minus 3m. What can I do with that? I cannot add negative 4 and 7 right now because the 7 is multiplied by something. We'll talk about order of operations in a little bit, but for now, just know I need to do this piece of it first. This is the distributive property. I can tell because I have something multiplied by a difference or something multiplied by a sum. In this case, it's a difference. So I like to do a little arc to remind myself that it's multiplying by the 1, or 1 by 7, and that minus 3m by 7. This becomes negative 4 plus 7 minus 7 times 3 is 21, and then my m. Now I can combine negative 4 and 7 because the 7 is not multiplied by anything. So negative 4 plus 7, think about that. We have two things of opposite signs. Add them together, so 7 minus 4 is 3. The bigger one is positive, so positive 3 minus 21m. Whoops, almost done. What did we forget? Take a moment. Pause it if you need to. Yeah, hopefully you came up with the fact that the variable term should be first. Negative 21m plus 3. Okay, another example. Negative 2n minus 9 minus 10n. And I'll let you do this one. Feel free to pause it and start working on it, or if you need a hint, hang on just 1 second and I'll give you one. This is a little weird because we have a minus sign and there's no number right in front of the parentheses like we had here. So what number could we put? What number can we multiply by without changing things? Well, we just learned that. The identity property, we can multiply by 1. So if it helps, throw a 1 in there and then work through it. Example 3, we have negative 10 times 1 minus 9x plus 6 times x minus 10. So we'll be distributing and then combining like terms. Number 4, 1a minus 2ab plus 3ba minus 4b. So at first you may look at this and think there are no like terms, but there are. There's a pair of like terms. You need to do a little something to find that pair. And then once you've done that, you can combine your like terms and you can put them in order. And example 5. 5u v squared. Notice I'm being careful to make sure my u's and my v's look very different. Minus u squared minus 4u v squared plus 2u squared v minus b. Okay, lots of terms. What I notice is that I have uv squared, u squared, uv squared. Okay, those are the same. U squared v, regular v. So I'm going to combine 5uv squared minus 4uv squared. I see those as having like terms. So let's go ahead and do that now. 5 minus 4 is just 1. I don't even need to write that. That 1, that is. So I'll write uv squared minus u squared plus 2u squared v minus v. Now I'm not done quite yet. I need to put these in the appropriate order. The first variable that comes in here alphabetically is the u. So I start with the highest powers of u. Got two options. These both have u to the second power. Personally, I do not care which way you put them first. I might put 2u squared v minus u squared. Then I have a u to the first power right here. So plus uv squared. And finally, no u's at all, so u to the 0 power. One question that I have for you is I didn't have a sign in front of here. How did I know to use a plus sign? So pause it, think about it. It's similar to what we did here. We had 3 minus 21m, and we switched it around. Basically, if we don't have a sign in front of something, it's a positive sign. So when we move it around, we can tack on that plus sign. Go ahead and look at worksheets 95 through 100, and I will have a video on those because those are just a little bit more complex than the standard worksheets. I'll see you there.